Hi, it's Mike Stevenson here. In today's video, we're going to talk about a question that was raised by one of my subscribers about logic app consumption and about the use of third-party systems in testing and how to kind of handle those dependencies. Before we jump into today's video, a quick thanks to our sponsors, Serverless 360, who are helping us grow the channel. So check out their product if you're interested in things like cost analysis of your Azure spend. You're looking for opportunities to reduce the amount of money you spend and optimize those resources and just get those costs transparent and under control. Check out business applications if you're looking to provide better monitoring and management of the solution that you're building in Azure. If you're looking for things like business self-service for transactions executing on your integration platform, whether it be Power Automate, Logic Apps, Azure functions, or some other technologies, check out Business Activity Monitoring and Azure Document that can help you automate documentation generation from the solution you've built in the cloud. Back to today's video. So I've got a kind of a snapshot from the email that Matt sent me. So basically, first off, great, he's loving the YouTube and blog content, so thanks for that feedback, Matt. So Matt works as a developer in the UK. So we're using Logic App consumption quite a bit over here, but I guess the problem is he's sort of coming to the point where he's got to test with the connectors connecting to different things. So he mentions that we've got things like function apps. So we've got SQL. So we've got SQL, function apps, HTTP connector, key vault storage, and the challenge is it's impossible to mock all of these out for end-to-end testing. And then he's also got other third-party systems that come into play. And if we're lucky, we get a test environment set up and the ability to test on it. So he's got these 5 questions he raised here. We're going to go through each of these questions, but I'm going to talk a little bit about the bigger picture as well of some of the things that you'll typically be trying to do. So I think to me this video, I've talked a bit about in the past about the Logic App test framework to do sort of automated testing, and we know that I did the version on Logic App Standard. There's a version available for Logic App consumption on GitHub and NuGet as well. And to me, that's just one part of a bigger problem. So that's really addressing the kind of how do we actually write a test and how do we test that run history. But there's bigger questions that come into play about your test strategy and your environment strategy. And I think these questions do a really good job of asking some of those kind of problems. So I'm going to make a few assumptions about Matt's situation. So I'm going to guess he's probably got an integration team. So he's probably got a bunch of developers on that team. They'll be working on different projects. So let's imagine we've got half a dozen projects on the go at one time. That's common for a sort of typical decent-sized organization doing multiple different initiatives at once. And the question is, what environments do you have? So you probably have a dev environment, and then you're going to have a production environment. And then there's the question of this process that you're going to go through to get you from dev to production. So I think a lot of Matt's question really comes down to what happens where that question mark is here. So how do we, what kind of things should we do and what would be good practices, what would be bad things to be doing to help our team get our solutions from development to production when we understand that we have multiple different projects going on at the same time over here. So let's just start really small. We think about a typical integration. I'm not looking at the multiple project scenario just yet. I just want to kind of recap a bit of what we talked about in the test framework stuff. So let's use this example integration here. So we've got a source system, publishes messages to an event hub here, and then we've got a logic app that receives the events. This one here would decide based on the type of message that I've received, I would call one of a number of child logic apps and they would load that into an end system. So a couple of things are, firstly, we've got to work out how do we test these logic apps on their own in each of the different types of environment, but also these logic apps potentially have other things they depend on. So in this case, it's quite simple end to end, but there might be a function, there might be a key vault, and there might be other stuff depending on how complex your logic app really is. So if we take an example from a typical test environment, so let's assume this is like a UAT environment. A lot of companies might have a scenario where you've got a tester who takes an action down here in this system. So maybe they click a button in that system or they trigger a nightly job or something like that. They would then let the integration run here, and then at the end they would be going into the target system to be able to see what happened. Now, that's very classically the manual UAT type testing you would see business users doing to gain acceptance of the interface. The big problem is here is they have no visibility of what actually happens in the integrations. That's one of the challenges. But that's the kind of thing most often we would see in a UAT environment. And then if we're in a developer environment, typically we're looking at trying to do something like, can the developer trigger the process here? But then if we start thinking about trying to test these sort of units of work here, you would have the developers also trying to trigger these logic apps on their own via some kind of unit test. And the idea would be, if I was building this, I would be looking to say, can I check this one works, get an expected input message? Can I check these three? Then I would be looking to check that one, then that one. Then I would test the whole end to end. So that's how I always use this analogy. If I was building a brick wall, I would put my bricks down, and then I remember my dad used to be a bricklayer at one point in time, and I remember he showed me how to do this a little bit, where he would kind of tap on that brick with a trowel as you place the brick to make sure it's solid in place. Then you'd put another brick, tap that to make sure it's in place, and then you would build it up. And then as you put your bricks on top, tapping each one as you go, the result is when your wall's fully built, it should be rock solid because you've secured every brick and tested that it's correct before you build it up. And what you wouldn't do is just put every brick down, wait till you get to the top, tap the top, and find out it falls over. So that incrementally building it up with good tested chunks of work, I think, is a good practice for a developer to be having. And then that means when we go to other environments like system test and UAT, you tend to have fewer problems. So if we think about the test framework now, so this is where, regardless of whether you're doing standard or consumption logic apps, you might run the test in Visual Studio. You've written some automated code. I quite like to use SpecFlow, but you might just write C# code. And the idea would be, in Visual Studio, you could make your tests trigger a given logic app and test that bit of work on its own. And then the thing you really want from these automated tests is the repeatability. So I can just click a button and they'll go and check that they all work. And then when somebody else on the team comes along later, they would be able to they'd be able to run those tests, make sure everything works as expected before we start making any changes. Now, when we're doing this automated testing, we have to be aware of limitations. So things that touch on points Matt raised. It's hard to check and trigger external systems. So if I'm this developer here, I'm building up my individual building blocks here, but it might be quite difficult for me to trigger something over here from my test because, for various reasons we'll talk about later on, but we might not have access to do it. There might be limitations on system availability and things like that. So I think this dotted line here, in the development environment, if you're the developer, focus on trying to make sure the bit inside your box works correctly. All of your internal logic apps work as they expect without having to get too much into the external systems. And this is really where stubborn and mocking comes into play. So if I can create something that acts like that system here, but doesn't actually call the system, then I can make it easier to do testing of my logic apps. So this is where we use stubbing and mocking approaches. Now, the key thing is sometimes it's easy, sometimes it's difficult. It really depends on what that system is, how you're going to integrate with it. So something like if your logic app uses the Dropbox connector, so you would have that API connector in Azure, and that would talk to Dropbox for you. Now, you can't easily mock that connector here. That's really difficult to do on both consumption and standard. So there's a few other choices we'll talk about in a minute or two that come into play. Now, your other options could be you could maybe flip between different target systems. So maybe you have a different Dropbox account for dev and a different one for test or something like that, where you can have more control about it. Now, that might be doable with Dropbox, but what happens if it's a third-party FTP site or a third-party system? That just gets more complicated. Now, you do have things like where if you're going through API management and you're talking to an external system, so let's pretend we're talking to SAP via the REST services. We're doing an OData call to query some data. And if I'm going through API management, I can create stub APIs here that might make it easier to test scenarios for my logic app and take away that dependency on SAP. Now the question is, do you want to take it away in all environments, which we'll come on to later, or just for your developer unit tests? So the thing we've got here about some connectors can't be stubbed. So that would be here where you can't easily replace the connector, but you can change the end system. APIM makes it easier to create a stub version of the API. With these ones, you're always going to have that reconfiguration by environment. So you're going to be wanting to make sure you've got a good DevOps process in place as you deploy across environments to allow flipping between stubs and real systems. There is a feature in logic apps called static response. So people just, if anyone's not familiar with that, so people are aware, you can, in your workflow here, you can have a specific action where you would turn on and off certain shapes to be able to be configured with a fixed response. So let's pretend I'm making an HTTP call. I can configure a static response, turn it on, and the logic app then sort of internally mocks that external system, so it doesn't actually call it. It would just use the internal response, but that's configured in the logic app. So in theory, this is a really good feature. In practice, I don't really find it useful because I can't dynamically turn it on and off. I can't easily control from a test which response will be used if I've got multiple or something like that. So it just doesn't really work in the real world, static response, in my opinion. But I would love to see Microsoft do more with something like that where I can configure a response. I guess the other thing to maybe note in here is Logic Apps Standard does have a mock capability. Because you can host the function runtime yourself on your local dev machine, and you can then do some injection into that host to control who it calls and stuff. So I've managed to do good stuff with that with HTTP connector. You'll see in the test framework on GitHub and in the integration playbook, there's some videos about how to do that. The big limitation though is you can't, again, coming back to these API connectors, you can't mock out an API connector because of how the security works behind the scenes. So it just doesn't really work. And I think you'll probably find that just becomes too painful to do. So you can do bits, it's just limited. If we put those limitations to one side, you can do automated tests where you keep that dependency on those external things. So maybe we have an FTP site we use in production, and then we have a test one that we can use for each environment, and maybe you have like a dev folder and a UAT folder or something like that. So you can achieve the ability to have automated tests that you would then run in a build. So here we see a representation where we've got Azure DevOps up here. The code gets checked into a repo, a build pipeline picks it up, deploys your logic app, and then it executes the same tests that you've had on your dev machine, testing all of these logic apps and doing certain things. And you would have applied the right configuration to talk to the appropriate systems. Now, there's a couple of questions here. So in practice, I think most of the projects I've been on, we would run these automated tests in a CI environment, or build environment. So we'd have a dedicated let's say we have a dedicated resource group where our developers would work against the dev resource group. They check in, our automated build runs against a build resource group, executes the test. The end systems we would use would be the same ones we would use in dev. So sometimes we might mock an API and sometimes we might talk to a dev version of a system. We'd run those tests and hopefully we'd get a good build coming out the end of this pipeline. So we'd have an artifact, or you could use the different branches if you wanted to trigger other builds off. So there's a couple of ways you can do that, but the key thing is you've got some reliable code coming out the back of that. Now, if we take a step back for a minute, some of the questions Matt had were around environments and dependencies. So I would say that as a minimum, so if we say we've got a dev environment, we've got a prod environment. Ideally, I would like to see a build environment. So that's basically an equivalent of the dev, but it's just a clean build environment. But you can still point at your dev systems if you want. And then you probably want to have a UAT. And again, this is where it starts varying by organization. So some companies will have many environments. I've worked with companies in the past where you might have 10 or 15 test environments. That would kind of be equivalents of that for system test, UAT1, UAT2. The more environments you have, the bigger the overhead in kind of maintaining all the other systems that go with it. The smaller the environments they have, the more you have challenges where two projects doing conflicting activities at the same time end up causing conflict between projects. So then you would often have an environment manager who would manage who can use what environment when. Now, if you let's say we've got three systems here. So we've got CRM, we've got SAP, and we've got in fact I'll draw these arrows both ways. And then we've got let's say we've got our HR system here. Now, in the real world, you probably have another 50 odd systems or 20 odd systems if you're doing a big integration project. So the arrows coming in and out of your dev environment get complicated. The other thing you would probably find, especially on logic app consumption, is in this dev area, you might have 10 or 15 logic apps that all use the HR system. So you start then having conflict between interfaces where different interfaces are using different different things in HR at the same time. And if you have an HR dev team over here building the HR system and they're adding new features and you've got two or three different developers changing HR interfaces, this is where it starts getting complicated and you have to start managing these dependencies. Now, in our build environment, if you had other copies of these systems, great, but if you don't, this is where, let's say this is SAP Dev, CRM Dev, and HR Dev. So we've managed to get it working okay like this, where your automated build pipeline would run, it would deploy everything to that clean environment. So your developers here write code on their machine. They would, if they're in the Azure portal, let's pretend, just to keep it simple, we've got a resource group for each environment. They're developing the interfaces, they're talking to those systems, that ad hoc running stuff, then they check it in, You do a clean build here in your build environment. Your tests run against these systems, and occasionally you might have, let's say we've got a mock here, you might mock out something as well. And the idea is to get that clean build where you go, yeah, we think we've got a good package of code we can start deploying now. You would then start deploying it to your other environments. So just to keep the diagram easy, I'm going to just have one test environment, but if you had multiple, you might start deploying it to each of them in whatever sort of fashion makes sense. That again, the more environments you have, the more complex that the overhead of managing what gets deployed where becomes. What I would say though is for your other environments, this is where it starts getting challenging. So you can probably get away with a lot of stuff in development. And to me, in the development and the build environment, you're trying to promote the velocity of being able to develop quickly, and you'll trade off reliability and you'll trade off performance and other things to be able to develop code quickly. So let's right. So when you get to the other environments here, you're looking for reliable and stable. So if you're if you in, let's say we're in UAT, so let's say we've got CRM UAT. So here, what you're trying to do is, let's say we've got this entire integration environment for UAT here. Um, we're talking to the UAT versions of each of the other environments. Now, this is where mismatches between systems start getting complicated. So you get questions about, well, let's say we have, let's say we have two integration test environments. So let's say we have system test and UAT. But what happens if we only have CRM has UAT, but CRM system test, you don't have one, but you do have SAP. SAP UAT is good, and SAP system test is good too. So now you've got a problem where we've got a mismatch here because we've got two SAP test environments, but only one CRM one. So there you get problems about, it's not just the dependency management of when I deploy it, what environment do I point CRM to my logic app system test? What do I point to? Because there's no CRM system test. So that's going to be a big problem because you're going to potentially have integrations that are going to push data between systems, and you don't want to end up with SAP's UAT system being filled with data from CRM UAT and CRM system tests or something like that. That's where you get that 2-to-1 or 1-to-2 problem. So trying, to me, when you're going for reliable and stable, you're looking for like a 1-to-1 relationship between systems, like environments and systems. So we want one UAT for CRM matches to one UAT for integration for SAP to HR. That makes it easy. When you've got 1 to N is where it's going to get difficult. That's where that we've only got one environment for CRM, so it's going to be problematic. So trying to keep your environments clean means your dependencies become easier to manage because you've got some stability between which systems point to which systems, which makes life easier. I think you will sometimes on a project find where you've got multiple projects going on at the same time, they'll be deploying different changes to different environments, particularly in those bigger customers, and then you have to manage, well, somebody can use UAT for this month because some changes are going to be in that will break something else, and they can do the other project two can do their testing in a month's time when other things have been deployed. So that's where it starts getting really tricky. And to be honest, there's no like in my opinion, there's no kind of silver bullet that makes that problem go away. It's just something where you need all of these teams, all these different applications will have teams or stakeholders looking after them, and you need to have communication between those teams to make sure everybody knows what each other's doing, to manage the different work being done by different teams, because obviously in addition to the integration work, driving integration changes here, there might be other things the SAP team are doing that have nothing to do with your integration work. So you need to kind of be talking to people about what's going on. The more environments you have, the more systems you have, in my opinion, the more you would require somebody to be responsible for environment management to coordinate everybody. So that's really what I think good looks like. I think what does pain usually look like? I've talked about that quite a bit, I think, on the previous slide about this, to me, this whole 1 to n is a problem. So let's just bullet point rather than diagram. So we've got environment, mismatch. Pain would be no communication. Painful would also be, in addition to communication, no plan. So in addition to comms, you need to know who needs to use what when. Sometimes certain integrations might be important, other times they might not be. To me, you need to know kind of like what's the architecture. So you need to understand the dependencies between these systems. So if we're going to change something here, how do we know that we need to change something else or test something else from a regression test perspective? I think that becomes really important too. Next up, let's talk about some of the questions that Matt had raised. So the first question we have is, should we try and deploy our entire infrastructure as a test environment? So I think the thing here is it depends which test environment you're talking about and what you're trying to achieve. So I think if you're trying to achieve stability, then to me, so we're looking for stability and we're looking to get reliability and get everything approved before we go to production. So I think in that case, you're going to be looking at a UAT type environment. And to me, I think you want everything in it. Now, I think if you think of the different types of applications and solutions we build, sometimes you might have an app that's very isolated, does quite a specific job, and doesn't depend on that many other things. And in those cases, it's much easier to really just be quite blinkered and only think about your app. But I think when you're building an integration platform, you need to think about the big picture all the time. And I think to me, if you only deploy just one specific interface, you may miss dependencies between other interfaces that you might not have really thought about have an impact on each other. So an example would be, I have an integration from CRM that goes through the integration platform to SAP. We're changing that and we test that it works, but later on there might be data that comes back out of SAP on an overnight interface that goes to the HR system. And if we don't think about the regression testing of that other interface just to be sure that it still works, we may miss that the changes we've introduced in, like, maybe they change the data or the behavior in some way that impacts something downstream later on. So that's why I think if you aim stability testing, you need to kind of test, not necessarily execute every single UAT test on everything, but you need to take a risk-based approach to your testing and be sure that other integrations who may have a slight dependency still work okay. So in that case, I would say for that kind of testing, then you want yes would be the answer to the question. If you're doing a different kind of testing, so maybe if you've got quite a big company where you've got lots of different environments, and you're wanting to do some project focused testing just on the bits you're working on, then you may not need to deploy all of the other infrastructure for other integrations and other systems because you're only focusing on just your bit. But I think if we imagine, we've got some kind of dev here, and then you've got some kind of build environment. And then from here, you might have project-specific environments. So let's say we've got project 1, project 2, project 3. And then you probably want to have some kind of like overall UAT or pre-prod. Um, and it gets called different terms in different organizations in my experience, but I think really what you're trying to do is bring everything together, make sure everything works in a production-like environment, and then you would go to prod. So if we look at this bit, the answer would be yes. If we look here, it would be maybe, and that would be based on your attitude to risk in those environments. So the next question, which branches should we attempt to run tests at? So I think with this, it really depends on what your branch and strategy is, how much time you're going to invest in your automated testing, and where you're going to do manual testing. So I would say if you're in your dev and build environments, then you would absolutely look to run those kind of spec flow type automated tests. They give you the ability. So I could, as developer one, I could pick some code up, write it, check it in, it builds good. 6 weeks later, Matt comes along, checks out the code, makes changes to it, checks it back in. So we get reliability that those are working well. In terms of other branches, so maybe you're an organization where you're deploying an artifact from the build to environments, or maybe some other organizations would have different branches for each environment where they would do pulls onto the different branches. And so in that case, it kind of depends a bit more. So let's say you've got system test. So here, the extra challenges you get are in dev and build. We're probably looking to mock. We're looking at small units. So there would be looking at testing one logic app on its own and maybe one or two together and that kind of thing. In system testing UAT, the challenges these tests would be much more end to end. And that makes the automation a bit harder, and you normally would have to involve other teams, and the actual testing would be more than just the integration team, because the chances are you're gonna either take the approach of mocking out quite a few bits, or you're going to take the approach of having to automate the end application. So this is where technologies like Playwright come in. You can do stuff with SpecFlow still, but you're going to have a bigger investment. Actually, I guess we'll probably have Selenium and other UI automation type testing there. So there's going to be a big investment in those tests if you're going to do a lot of them. So you need to be aware of things like changes on that the other teams are making to the applications and how these affect the test. So I think in this case, the more that you want to do the testing, or the more automated tests you need, the more you need a dedicated test automation team. Okay, so at the same time, while you are doing, here we're really talking about automated tests, but you probably still will have manual tests as well. The good practice here is to make sure you've got some tests, whatever they are, as long as they're ran regularly and that they're good quality. Whether they're automated or manuals really just depends on the value you get from automating it versus the cost of doing it. Obviously, automated has the benefit that they can be easier to run on a repeated basis and overnight and stuff, but there is work to maintain those tests and there's work to get them up and running. So I think for me, these branches would be a minimum. These branches would be nice to have to automate them, definitely do manual. I think the other thing you need to think about here as well with these tests is there's a much bigger data dependency. So that makes some of that automation more difficult, because if you let's say you want to put an order into your CRM system, that flows to another system, you might have to do a lot of work to set that order up in the CRM system and create a customer and all that stuff. And that's all, to me, that's all stuff that's kind of outside of the integration team's remit and scope for many organizations. And you need to understand how the CRM system works to create orders. So that really comes back to this test automation team here. But to me, the idea of a pragmatic approach to this is really what's important. If you're thinking about reducing risk and you're thinking about being pragmatic, where we invest an amount of time to get good tests that'll help us, and if we find that we spend loads of time just writing tests that don't really give us any value, then that's not a good place to be. Okay, the next question. What if there are shared components in different repos that we don't have control over when we're attempting to deploy? So this is really all about dependencies. Now, I think to me here, if you think of your bigger architecture, you don't necessarily want to deploy everything all of the time. So if we think about APIs and interfaces, if I'm changing, like let's think of that analogy before where we had that brick wall. So like when we've built integration solutions, we always kind of think of micro integrations, this small unit of deployment that does a piece of work that we deploy. It does a job. We test each component on its own, and then we do tests when they're working together. And then they would, talk to the various systems. Now, let's say this block here is something that has a change to it. What I want to be able to do is to swap that block out and swap in an update to that block without having to worry massively about everything else. So I would say when you deploy that UAT environment, that end-to-end has everything in it, you need to include all of your shared components, and then you just need to manage it as a dependency from that point forward. So if your shared component needs an update, then hopefully you've decoupled them in a way that makes them have fairly loosely coupled dependencies, so you can easily swap them in and out. So if you're doing things like that, then obviously sticking stuff behind APIM is a good thing, because that'll give you a separation between say a logic app and a service that it's consuming. You've got things like, if you've got something like Service Bus, or maybe events, event grid, event hub, etc. If you've got stuff like that in your architecture, then you can again decouple these logic apps that work together to be based on messages that they're receiving between each other, so you don't have these tightly coupled dependencies between logic apps. But then, that being the case, even when you do have the dependencies, so say for example you've got a logic app or you've got a function, you can deploy updates, particularly if you're on logic app consumption. You can deploy an update to that logic app if some other logic app's calling it, without it actually having downtime or breaking anything, unless you've put a break and change into it. So again, that would come back to managing your dependencies, understanding, this brick wall scenario here. Let's say we understand the dependencies between these bricks. So when you swap one out, these are the things that might be impacted by that. And then I think that way it gives you a way of treating shared components as just being a building block that you only really depend on the interface to that building block. So you should be able to swap it out. And then depending on what kind of building block it is, you should be able to do things like, if you've got a good interface model, things like a function should be able to live in a separate repo with a separate deployment pipeline, and you can just patch it in. And I think that this, to me, it's very doable to have a quite good pattern on this, as long as you're just aware of the dependencies and you kind of manage and track them. Okay, should we try and create a mock API that can simulate responses from a third-party system? So yes, would be the short answer. The long answer would be it depends a little bit on how complicated that third-party system is. Is it something that actually, when you're doing a test of your logic app, if there's not a lot of data dependencies on the third-party system, but the messages can be quite big, it can be a bit of a pain to do it. So sometimes for a given integration, it might not be worth it. But as a general rule, if you get good value from the mock and it doesn't take a lot of effort to develop it or maintain it, then yes, it's a good thing to do. Um, Certainly in the dev and the build environment, that's definitely a good thing to do. I would say if you're in a UAT or system test, I would say ideally not. So in those environments, you really want to test that. It's not just about your logic app at that point, it's about the end-to-end integration, and those systems are part of that kind of end-to-end transaction. So you need to make sure they all work together. And this is where, things like the environment management piece, that all kind of comes into play at that point. Have you got enough environments? Have you got a SAP and a CRM for UAT? And are they dedicated, or are they shared by other environments and that kind of thing? Assuming we can do some testing, where in the CI/CD process can we put these tests? So if we think in the CI pipeline, that would definitely be a yes. So if you look at the Logic App test framework videos that I've got, they show you how to do it with Logic App Standard, plug it into a pipeline. You can pretty much do the same technique with Logic App Consumption, just using the consumption framework. And then when you check in, you do a build, it'll deploy it to your build resource group, run all your tests, and just make sure everything's really good. And then there you're just simulating the unit test scenarios for each Logic app. That'll give you, to me, if you do that well, it often would give you a really high level of confidence that your Logic apps do what you expect them to do before you go into an end-to-end test environment, considering other stakeholders and other applications. So it's always a good thing. You don't want other people blaming integration for things not working. So if you know your stuff works before you put it in, hopefully you'll focus much more on the business requirements and the application requirements and not what the integration's doing. If you're doing So you can put tests in a sort of continuous deployment pipeline to do different environments. So let's say you're deploying UAT or system test. You can do it there, but it's a bit more work because that brings in the other challenges about what is a value test there. So in your CI pipeline, you can mock everything out, but in your UAT and your system test one, you really kind of want to have that end to end. So here you probably have a different suite of tests, and you might, this is where people would tend to use Playwright or Selenium or one of the other UI automations to automate the application as well as the integration. So I think that's probably worth thinking about the difference between the types of tests you would run at different parts of that process. I think one other thing I'd maybe just mention on here, I didn't really go into it too much. So obviously everybody knows that I do a little bit of work with Serverless 360. And I think one bit of experience from real world projects people might want to think about. So let's say, that diagram before, we had the source application, fires it into our logic apps. And then we had, other systems over here doing various things. And, maybe you then have a process coming back the other way where you've got more logic apps, and that goes back to that system. Now, one of the things we did a lot in Serverless 360, we've got the BAM module. And that, if you think about the challenge of particularly the manual testing, but also potentially the automated testing. So let's say we have a user or we simulate a user doing something here. This happens, then the user approves something here, which causes this thing up here to happen later. Now, first off, that if it's manual, these test users can't see what's going on in this architecture. They can see the applications, they have no visibility here, which is a problem for them. So one of the things we've done quite often is we'll use BAM to send key business milestones from our logic apps or functions, APIs, Power Automates, or whatever, to BAM, and then that allows our application users here and UAT testers, if they want to check what's going on, they can actually see near real-time execution of the integrations in BAM, presented to them in a user-friendly way, which actually, if we think about what we're really trying to do is understand if the system works well. So you need visibility and you need monitoring of that. And that can be achieved in BAM without the user having to worry about which logic app was it that does this bit. They just see these business transactions. So maybe here we're flowing an order across this way, and they can go and check in BAM and see where the order is. And then you could potentially, if you really wanted to, you could maybe drive with your automation, looking at BAM data from Selenium tests or something like that, or Playwright, to see the BAM transactions that executed related to your integration. So I think that's quite a good scenario. We may talk about that in a future video, I think. Okay, so the takeaways today then. First off, big thanks to Matt for the questions. There was a really sort of good set of questions. I've quite enjoyed just brain dumping a whole load of stuff on this video. So key things, testing can be tough in the big picture. So hopefully I've talked about why that's the case and talked about the difference between unit testing, which we've got a really good way of doing with logic apps, but then when it becomes the bigger end-to-end testing, there's other things come into play that aren't technical. So this is where thinking about your test strategy and your environment strategy is really important. You need to get other people involved to define that, and I'd say really keep, the earlier in a project life cycle you can do it, and the more you can keep on top of it, the better it'll be for you for future projects. Doing that well leads to good dependency management, which is the key to all of the technical questions about what repos can we deploy when, how can we test different things when there's conflicts between stuff. I think you will have, in a big project, you will have different projects with different concerns. You need to understand a cross project, which is that's just a project dependency versus a technical dependency. So hopefully this is where the architects on your integration platform can see those relationships and can help you do that effectively. When it comes to the test and automate where you can, I think for most companies there'll still be manual tests. Please maintain your manual tests, because lots of companies I've seen where you go in and they had tests when the project was first done, but then the project finished and everybody forgot what SharePoint site they were in, and 6 months later there's a change and nobody knows where all the tests were done previously. So regardless of whether they're automated, manual, or a combination, try and have a good structure to how you maintain them. The next one I would say is don't try to be perfect. It's a hard problem. To me, it's about reducing risk, improving reliability, and getting stability so that the stuff you deploy to production, you can get it into production without worrying too much about how much risk you're taking by a deployment. And I think that's where, if we think of a seesaw, we're kind of managing that relationship between velocity. So they're the two different types of testing. The velocity testing is the automated stuff that lets your projects deliver quick and agile. And then stability testing is about getting ready for production, making sure you've got rid of risk. They're the two different types, and hopefully that gives plenty of ideas about how to handle that in this video. I hope people have enjoyed this, found this useful. Feel free to ping me with other questions. I'm going to have a bit more time to spend doing YouTube stuff during 2024, and I love to hear from people what they're struggling with, what they'd like an opinion on, and that kind of thing. But have a great new year, and hope everyone has a good time in 2024.